Hello, statistics students. Welcome to another video on modeling linear trends. In this video, we'll look at example 3. Salaries of college graduates. The scatter plot shows the median starting salaries and the median mid-career salaries for graduates at a selection of colleges. And the source is the Wall Street Journal salary increase by salary type. And we'll go through letters A through E. Letter A. As the data are graphed, which is the independent and which the dependent variable? Because we are using the start median salary on the x-axis to predict the mid-career median salary, that means that the mid-career median salary is dependent on the median salary. The horizontal axis is always the independent variable, and the vertical axis is always the dependent variable. We're using the starting median salary on the horizontal axis to explain what the mid-career median salary is. The mid-career median salary depends on what the starting median salary is. Therefore, our independent variable is the start median salary on the horizontal axis, and dependent variable is the mid-career median salary on the vertical axis. Why do you suppose a median salary at a school is used instead of the mean? So we have learned about summary statistics before, and we use a median when our data is skewed, and we use a mean when the data follows a normal distribution. And salaries are typically skewed. And you can see by the scatter plot that there are a lot of lower start median salaries and a few high start median salaries. This tells us the data is skewed. We've seen that salary distributions are typically skewed. So medians are a much more meaningful measure of center with skewed data than means. That's why we used a median here. Using the graph, estimate the median mid-career salary for a median salary of $60,000. So we'll go over to the 60 for the 60,000, and we'll go up to the red line and then left to make an estimate from the line. Not really an accurate way to do this, but we see it's somewhere between the 125, or let's say between 110,000 and 120,000. It's the equation that's going to tell us more accurately what that prediction is. So if we use the equation to predict that, then we're going to replace the start median salary with 60,000. We're going to replace it with 60,000 and calculate what the prediction is. So for this one, it's important to realize that we're using thousands of dollars per year. So we're going to plug in 60 for the starting median salary. So we plug that into our regression equation, and we take 1.989 times 60, which is 119.34, and then subtract that from the y-intercept of negative 7.699. We get 111,641. Remembering that when we used the line to estimate that, we were able to say it somewhere between 110 and 120,000. But the predicted value is more precisely stated as 111,641. What other factors besides starting salary might influence mid-career salary? So think about someone has a starting salary and then they get to their mid-career. There's many things that could affect that salary other than just the starting median salary. Some people are very ambitious and go out and get extra training. Some people work a lot of hours. Some people advance in a job. Sometimes, unfortunately, gender can determine a salary. So number of hours worked, additional education or training after being hired, the gender, the type of career you have. Some careers give more money than others as you move up the scale. And this concludes this video on modeling linear trends, example 3.